Okay, everybody. What we're going to do is our normal lecture for today is going to be on YouTube instead of on Zoom. I did the Zoom, but I had to erase the video and we are redoing it. So anyway, let's just go ahead and get started. So first thing is we'll check out modules. We'll go down to week 3. There's not very much in week 3 yet. The announcements I need to make here are, first of all, you can see the meeting for the Computer Science Club. If you're interested in that, I suggest you check it out. Fridays at 3 p.m. in IAC 139, and you can sign up on a form, and you'll get an email from Kathy Hanamoto when about the club, basically. Also, you can check out the latest opportunities on the computer science blog, which I clicked on, so it's here. And so you can scroll down and see what there is. Lots of stuff. Just upcoming internships, upcoming research opportunities, and that kind of stuff gets posted here. Okay. Lastly, there's Zybooks information. So as of Friday last week, if you're in Follett Access and you need to get a code for the Zybook, then you can get it from the Merced College bookstore now. Okay. They have them in person. If you want to go and pick them up, I think they're on a little card with a code. And if you need to pick one up at the bookstore, but you can't go to the bookstore, you can talk to Merced College bookstore via email, and maybe they can get you the code electronically somehow. I'm not sure. If they won't, and you really need to work that out, you can let me know, and then I'll try to figure out what to do about that. Now, if you are opting out of Follett Access, then you have until September 8th to do that. So just remember that. And, probably a lot of you are opting out. And keep in mind that you need to do that manually. Otherwise, you're going to be charged $25 per unit for every class that you're in. Okay. Now, if you are purchasing it directly, the book, then you need to subscribe soon, like this week soon, because now that the book is available to everybody, I am going to start having assignments due regularly every week, starting next week. So you'll need access to the book this week somehow. And if you have not had access so far and you're going to buy it directly for the $77, all you need to do is just click on one of the Zybooks links, and I can't show you what you're going to see exactly, but I can show you the Zybook, and it looks just like this. The difference is when you log in your first time, you're going to have a panel over on the right hand side that basically just says you can enter a code for the class, or you can pay $77, and it should just be available after you click on one of the assignments. Okay, so after this week, we're going to be using it more. So back to modules, back to week 3. And so that's pretty much what I needed to talk about before we get started. Also, what we're going to have this week for assignments is today we have a class assignment, which is called Basics Lab. That's what it was called last semester. It's on variables, and it's similar to the lab, or similar to the discussion from last week. So we're going to be doing that today. On Wednesday, we're going to have our normal Zoom lecture at the normal time, and we're going to be talking about branching, which is also part of that Basics Lab. And also, there will be another lab on Wednesday to go over. Okay, so it's not here now. There's just a blank spot for it. But on Wednesday, there'll be another lab to do. And so if you look at the module for right now on week 3, what you've got is it just says week 3 and then the basic variables lab, which is what we're going to look at soon. But there'll be one more thing that's due down here. Okay. And so you have those coming up. Also, wait, why is that? Okay, there we go. Also, lab 1 from last week is due Wednesday. So you need to do that. And also, discovering variables from last week is supposed to be due today. Probably you're watching this video after Monday. So this was already due. So this was a discussion board post where you had to make a discussion board post. So this week there is no discussion board post, but the one from last week is still there. Okay, so yeah, I think we're about ready to get started. Before we do this week's material, I do want to show you a thing in Eclipse, which if I could spell Eclipse would help. Okay. So let Eclipse open up. And there we go. So I had a question from somebody about Eclipse, about setting up a project. And basically the issue was, and I will open up Notepad here to say something. So basically the issue was this. So they were using a Mac. I don't know if this is true for everyone. The options were slightly different when making a project. Or rather, not really that the options are different, but the default were different. Okay, and so what was wrong? I'll show you right now. So if I go, and I'm trying to make a blank Java project to get started with my programming. And so I go File, and then I go New, and then I go Java Project. Okay, and I type in the name of my project. I'll just go ahead and I'll type in Basic Variables Lab, because that's what we're going to be doing. And here's what was different. So on mine down here, you see where it says module, and it says create module info.java file. You want that unchecked for right now, okay? Unchecked. So I can check it. That's how it was for the student who had a problem. You want to uncheck that, okay? Uncheck that, hit finish. And you'll know if it's right because in what has just happened? Okay, I'm going to delete this project real quick. Delete that. Okay, I'm going to check something real quick while we're doing this. So I had that. I mean, obviously, I definitely had that unchecked. But so it's unchecked and I'm not going to check it. I'm going to hit finish. And there's nothing under source. Okay. Delete. Do the same thing. I'm going to check it, uncheck it, and then I'm going to hit finish. No, it's correct. Okay. There should be nothing under source when you get started. So you want it to look just like it looks here, where there's nothing under source. I have my old projects down here. And then if I right click on source, and I'm going to go new class, I name my class, this can be anything. So like basic variables lab can be that. No spaces, anything like that. Just basic variables lab. I'm going to use underscores to separate the words. I'm going to check the box for public static void main because that will create that function that I need. And I've got a name, I have that box checked, and then I'm going to hit finish. And this is our, basic project now. That should work. Just to make sure it works, delete that comment, I don't need it. I'm going to say system dot out dot print line should be working, semicolon at the end, and then I'm going to hit run. Should be working. Okay, so it is working. It is working. Okay, so let me put my name on top. Name in a comment, and then let me put the date. And the assignment. Okay, so we're ready to get started. I'm going to hit save, so that's file saved. And we will come back to this in a minute. Let me just check that we're recording okay. 11 minutes, sure. Desktop being shared. All right, and we were using actually this web browser. Okay, so here we go. And, so far so good. And this week, what we're going to be doing at first is we're going to be looking at variables. I'm going to click week 3. And for Monday, you'll see that I have the same lecture slides from last time, variables there. We didn't finish the last 5 or so slides. So we're going to look at the last few slides, and then we're going to do this class assignment together. So let's hit variables. I'll just download it. Open, sure. All right. Let's close that. Variables PDF. So I think where we were was near the end, like 35, 36, 37, 38, something like that. So let's try page 36. 37. This is where we finished up. We finished up talking about the mod operator, which you remember was the remainder when you do a division. And then where we were about to start was the plus plus and the minus minus operation. So it looks like it says minus, but that's minus, it should be minus minus. So what are those operations? Let me show you. So let's go back to Eclipse and let's modify this code I've got here. This is not really the lab yet. This is just, I'll just use this to, temporarily work through some things. So if I say this, if I say A equals, actually, let's do integer, A equals, let's say 5. Okay, A is 5. And then I change my system.out here, and I'm going to write this. System.out.println, open parentheses, and then I'm going to say A is space. So A is in quotes, space, plus, space, A. And that's it. And I'm going to run that. I'm going to run that, and you can see it says A is 5. And there's no gap between the is and the 5 because I needed to leave an extra space there. So now A is 5. Okay, now that's one way to say A is 5. Another way to do it would be if I used a system.out print like this, and I printed the A is there, and then I did system.out.print A like that. Should get the same thing. Run. And of course I do. And I could even use a print line there to make sure it goes to the next line. I'm doing this for a reason. The other style was fine. Why is that highlighted? I don't know. So anyway, I'm just printing that 5 to the screen. But the reason I'm doing it is because I want to show you something. I'm going to put the same 2 lines, copy paste them. I'm going to do them again right here. And I'm going to run that. And of course, it should just print this twice. A is 5, A is 5. Okay. Now, if I change the system.out.println A and I put a plus plus on the end. So it says system.out.println a plus plus, and I run that. Look what happens. Okay. So when we do a plus plus, here is what happened. So a plus plus. First, there's two things that happen. A gets used in the line of code. I'll even actually put this whole line here. So first, A gets used in the line of code. So it was 5, right? A was 5. That's why it says A is 5. Second, A 1 gets added to A, right? So what's happening on this line is that first we're using the value of 5, and after it uses it, then A goes up by 1. So then when we print out A again on lines 14 and 15, we get a 6 because the A plus plus made A go up by 1. Okay, that should make sense. And you're wondering why I'm explaining this like this. The reason I wanted to explain it is because if we change that line to this line, plus plus A, then what's going to happen is this is going to be reversed. First, 1 gets added to A. Second, A gets used in this line of code. Okay, so if I change it, I put the plus plus at the beginning, plus plus A, then I'm not going to get 5 and 6 anymore. I'm going to get 6 and 6. 6 and 6, right? Because now we're adding 1 to A, but we're doing it before the rest of the line is going to happen. Okay? So that's the difference between a plus plus A and A plus plus. They both add 1 to A, but one adds it after the line and one adds it before. So we use it and then add 1, or we add 1 and then we use it. Okay? So that's what's going on there. And minus minus is the same, except it subtracts 1. So, right, remember if we do A and A, run, we get 5 and 5. If I do A minus minus, then we should have 5 and 4. We're going to use the 5, and after we use it, then we're going to subtract 1. So we should get 5 and 4, which we do. If I put the minus minus on the beginning, now it's going to subtract 1 first, and then we're going to use it. So we should see 4 and 4. 4 and 4. Okay? So that's how minus minus and plus plus work. So let's go back to our PowerPoint. Precedence rules. There's not really too much we want to say about this. They mostly follow the rules that you would expect for like regular math. So let me just show you. Go back here. We don't need 2 lines anymore. We can just do like this. And instead of A equals 5, we're going to do this. 3 times 2 plus 10. Okay, now what happens here, actually let me change it. 10 plus 2 times 3. When it changes the order there. So when you have this right here, you follow the normal math rules. And so the normal math rules for 10 plus 2 times 3 would say that first the 2 and the 3 get multiplied and you get 6. And then after that, then you would add 10. And that's because multiplication is higher precedence than addition. Right? You do multiplication before you do addition. So this should be 16. So I run it A is 16. Okay. And yeah, I mean, that's really it. So if you do this, something like this, 2 times 4 plus 3 times 5, right? Of course, the 2 times 4 is 8. The 3 times 5 is 15. So this is 8 plus 15, which is 23. Run. A is 23. If you put a minus on the outside like that, that's higher precedence. So you can pretend that that's in parentheses there. So it's like -2 times 4 is -8. -8 plus 15 would be 7, right? Run. 7. And even if you take off those parentheses, you're going to get the same exact answer because, again, think of the negative as being attached to the 2. So first, highest priority would be that negative. The next highest priority would be multiplication. And after it does all the multiplications, then we can do addition and subtraction. Those are regular rules for for math. If you want to change those rules, not change them, but if you need to do an operation that deviates from that, you use parentheses, right? Like if I go back to something we had before, like if I do like this, 10 plus 3 times 2, something like that, we know that this is going to be 16, right? Now, what if you want to do 10 plus 3 first, right? 10 plus 3 is 13, and then times 2 to get 26. What if that's what you want to do? Well, it's not going to do it the way it's written. You would have to, in order to make that happen, you would have to add parentheses yourself like that. And if you have in parentheses 10 plus 3 and then outside times 2, then this would be 26 because it's going to do 10 times 3, which is 13, and then 13 times 2, which is 26. So you can use parentheses just like you would in regular mathematics to control that, to make that addition happen before the multiplication. But you have to use parentheses. Okay? So those are really just basics of how that works. Here's an example in the PDF here. Like, for example, cost plus tax in parentheses times discount would mean that the discount gets multiplied after we add the cost and the tax. And if you write cost plus tax times discount with tax times discount in parentheses, of course, the tax and the discount are multiplied together first, and then the result is added to cost. Okay? So it works just like you would expect. And here's some examples just to show you. The main ones that you'd want to pay attention to, I mean, you should pay attention to all of them, I guess, but notice that this last one here, if you're trying to do something like a fraction, and in the numerator you have a minus 7, and in the denominator you had t plus 9v, just when you have a big fraction like this, just imagine putting parentheses around the numerator and parentheses around the denominator, and then you'll be fine. So the way you would do this fraction here, a minus 7 on top, t plus 9v on bottom, is you would say parentheses a minus 7, and then after you close the parentheses, a slash, and then your denominator is also in parentheses. So in parentheses, you have t plus 9 times v. Also, when you see things like 9v, remember that when you type them up, you're going to have to manually put an asterisk for multiplication. You can't just say 9v, you have to say 9 times v. Okay? And that's it, really. So, and then code structure, but we don't need to look at that. That's just like one random slide on the end there. So anyway, that is the end of that PDF that we didn't quite finish on Wednesday last week. And now what we're going to be doing is we're going to look at that basics lab, okay? Which I'm going to change the name so it's called Basic Variables Lab. But right now it just says Basics Lab. So let's click on it. And we'll go through as much as we can here. So it says we'll go over these questions in lecture on Monday. That's what we're doing. You have to answer these questions yourself, and you need to submit your work as a PDF or by copy pasting it into Word and adding in answers. Okay, and you submit it by September 5th, which is a week from today. Now, one thing I will say is this. So let's just download this first. We can look at it. Download. Let's open it. Okay. So when you look at this, let me zoom in. Java Basic Variables Lab. And there's just 10 questions, and you are supposed to kind of put in your answers. Now, there's nothing stopping you from just like in Microsoft Word or something, like Word, blank document. Like there's nothing that stops you from just, put your name on top and everything. I don't really care about the formatting. What I call it, Basic Variables Lab. I don't know. Right. Can I make big? Yeah. Okay. So there's nothing that stops you. You just you can do that, and then when we start on the first problem, which of the following are good variable names in Java? Why? Like write Y, and then you can get started. So you can go one. Which of the following are good variable names in Java? Then write Y. If they're not, you have to say Y. So like I'll say A was A, B was num5, num5. And so like you can do this, and notice that I'm having a little bit of trouble with it because, it's changing the capitalization when I don't want it to, and so on. And for that reason, I don't really like answering questions like this in Microsoft Word. What Although it's perfectly easy to do that, but it's annoying as well. So I don't like that. So I want to give you the opportunity to use software that I call software called Overleaf, which will it's what I typed up the lab in the first place. So this lab right here, where we've got problems, and then when I need to write code, I can make it look like code. Right? How this looks different. When I want to write code, I can write code. And you can use this same software that I use to type this up to type up your work if you want. So if you look at the Basic Variables Lab, it says LaTeX source in case you want to write your answers using Overleaf, optional, completely optional. You do not have to do that, but you can. Now, what do I mean when I say it says LaTeX and notice there's weird capitalization? Well, that's not actually latex. It's the word LaTeX. So it's pronounced with a K, LaTeX. And what it is, I'll click on here, the LaTeX project, so we can see it. It'll say it. High quality typesetting system. It includes features designed for the production of technical and scientific documentation. De facto standard for the communication and publication of scientific documents. Yes, this is what most textbooks are typed up in. This is what your research papers are typed up in, right? Anything that we do, like in science and technology, is often typed in LaTeX, including what I type up for you. So we have this software, and it is kind of, I'll say, it's not that hard to run in like Windows or Mac OS or whatever. It's not that hard to run, but I don't generally run it on my own computer anymore because the online things that you can use for compiling LaTeX code are nice. So that's what I use. So I don't use the default like on my own computer. What I do is I go to overleaf.com. Here it is. It says LaTeX Evolved, easy to use online LaTeX editor. And you, unfortunately, if you do want to use it, you have to register. You can just like hit register and like use your Google name or whatever. I'm already registered, so I'm going to hit login. Log in with Google. Choose my account. Oh, I need a password. Two-step verification. Send it. Oh, I didn't hit the send. I was like, where is it? All right, what is it? 806-227, and I'll say don't ask again. Because I'm using Microsoft Edge today. Okay, so there's already a basic variables lab in there. You know what? I'm going to delete that. Trash it. Confirm. Okay. So when you first do this, you're not going to have any projects, but we're going to make a project. So what I'm going to do is I'm going to download this LaTeX source. So I'll hit download. This is just a zip file. So I'll just save it. Downloads. Sure, why not? What is pining for the good old days files? I have no idea what that is. Literally no idea. All right, anyway. So I saved this file. I'm going to open this up here. And there it is. So CPSC 6 Basic Variables Lab. Now, if you look in that zip file, it just has one file. And that's actually a regular text file you can look at. It has a TEX extension, not TXT. TEX is for tech. It's to tell you, it's like think HTML. TEX is the LaTeX extension. So just that one file. So I could extract it if I want. I don't want to. What I'm going to do is I'm going to go into Overleaf, and I'm going to say that I'm going to make a new project, and I'm going to say that I'm going to upload a project, and then I can either select a zip file or I can just drag and drop a zip file. So I'll drag and drop that zip file I just got from Canvas, and we get this. So here's what's going on. On the right part of this is the PDF. Okay. On the middle section, I'll call this the middle section, to the left of that, you have what looks kind of like HTML or something. I kind of make it bigger here. So you can see that there's like document class up here, article, there's some stuff that says used package, etc. It's hard to read. You know, you're not trained to read this right now, but you know, you have some of that. You have a heading, left heading, right heading, center heading. That's for dictates what you have at the top here. That's the CPSC 6, etc. Oops, scrolled on accident. Go back up to the top. So you have headings, and then the document starts, and then there's other stuff in there here. So basically, you can edit this, and when you hit the button that says recompile, it makes the PDF. So like, for example, if you were going to, you could do this. I can, first of all, I should put my name on it, right? So if I wanted to, I could just comparing the left panel to the right panel here, right? Java Basics Variables Lab. That's here, begin center, Java Basic Variables Lab. So if I want my name above that, I could say like name, again, date, that maybe. I'll put a blank line between those. Otherwise, they'll end up on the same line. Hit recompile. And okay, look, see, I got my name on there. Okay, good start. And the thing is that what I can do is I can basically do this entire assignment by editing this document rather than making my own in Microsoft Word. And if you want to, you could do your assignment that way as well. It's up to you. Okay. Or you could just use Microsoft Word, right? Just go back and start typing in there. So with that said, let's go ahead and get started. So if we are trying to do this, we need to look at this PDF, and I'm going to put the clips over here and try to get them both on the screen. A little bit tricky. We'll have to kind of scroll through, and let's try to do this. So problem 1 says, which of the following are good variable names in Java? If they're not a good name, then write why. Now, this is a little bit unclear. I did not write this assignment, but I'm just copying it. So when they say what is a good variable name, well, what's good? Because there were some things that you have to do, and there's some things that they told you you should do. So like if I try to make these as names, I'll just start declaring variables, right? If I do int a, of course that's going to be fine, right? If I do int num5, that's going to be fine, right? So these are fine, and I'll even label them. Good name. Bad name. Oh, why did I say bad? That one's good. Good name. 5 num. That's an illegal name, right? If I try to compile this here, I hit run, it'll tell you unresolved compilation problem, syntax error on token 5. You can't start a variable name with the 5 there. So we can't even do this. So let's comment it out. But that's bad because that's actually it's not just a bad name. It just doesn't work, right? It's illegal. That's an illegal name. Okay, not just a bad one. All right, let's keep going. Long 5. That's allowed. See, there was no errors when I hit compile and run. No errors, but that's not how we were told to name things, right? And also long is a variable type, right? Like I can do like this. Long 5, right? Like that's legal. But it's confusing to have like a long and then the variable name also starting with long. So that's not a good name, but it's not disallowed, right? So, it's allowed, but it's still a bad name. You shouldn't use it. But not good. It's allowed, but it's not good. I don't need to call it that long. So it's not really a great name to use, but it's not illegal. Underscore, you can't start that with can't start a name with an underscore. You can use number scores, but you can't start a name with an underscore. So when I do run, I lied. I just lied. You definitely can start a name with an underscore, but you shouldn't unless you have a good reason to. So this is allowed, but not good to start with an underscore. A, B, C, D, E, F, G, that's allowed, but also not good because they told us because the naming scheme they told us to use was start with a lowercase letter first, and then every word that you add should be start with an uppercase after that. So like this is how we're supposed to name things according to what I've told you, right? So like this is a good variable name, a variable name, where you start with a lowercase letter, and then after that, every new word as you in your variable name should start with a new capital letter. Okay, so obviously this A, B, C, D, E, F, G doesn't follow that rule, so not good. Sum.5, you can't use periods. illegal because of the period. So if I try to run this, I get a syntax error because of the period. So that's not allowed. Next row, integer 5 with a space. That's not going to work. Now, I did copy paste this from something, and then I realized that maybe I didn't. Maybe there were some formatting issues. But integer 5 is not a proper name, because there would have to be like integer underscore 5 would be allowed. Integer space would not be allowed because of the space. Can't have a space in a name. So I can't even compile that. If I try, I'll get an error. And it's because it thinks that 5 is a new name, but you can't name something 5. All right, what's next? Rate 5, that should be allowed. That's allowed, right? Again, it violates our rule for how to name things, right? It should be, if we're following the rules, it should have been like rate 5 like that. We should have started with a lowercase word. Total -5. I think there's an extra space in here that shouldn't be here, but if you copy paste from here, that's not allowed because of the dash in there. Can't have a dash. So I try it, I'll get an error. Right, so can't have the dash. %car5, you can't use a percent. Can't use a percent in a variable name. And then finally, short. And you can't use short as a variable name because short is a data type. So, right, for example, like a short is a 16-bit integer. So you can't you can't give short as a name to a variable, right? So that's not allowed. So this will be an error, right? Invalid variable declarator. Can't use that as a variable name. Okay, so most of these were not good, right? Some of them were illegal. Some of them were legal but bad names. And the only ones that were good names really were A and num5. The rest had something wrong with them. They work, but they weren't great. Okay. And so you need to communicate that information in your write-up. I can copy that. I just copied that text. And, if you're doing this in Word, you would go to Word, maybe erase that, try to paste it. Oh, paste it in a really bad way. So I'm going to undo that and then go, okay, well, maybe I should just paste, keep text only. Okay. That's not that bad, right? That's not that bad formatting. So maybe that's okay. For saying what's wrong. Now, if I want that to go into overleaf, here's how I would do it. So I already copied that. So what I can do is this. So you'll notice on line 58 here, it says begin. And then in here, it says LST, that's LST listing. I always read that as listing, even though there's no I in the first list, but listing. And what that line is doing is you're telling it that you're going to put in a block of code, right? So over here in the PDF, you see how the A, the num5, like all this section down here looks like programming code. It's in a different font and everything. Well, anything that I put in between a line that says begin list listing and end list listing is going to be formatted like code. So I can just erase this now, what was there, and I can just paste in what I had from Eclipse now between those. And if I hit recompile, I've got my answer to the first question here. Right? And so I think that's a pretty good way to do it. And if I use overleaf, I don't really have to worry about the formatting for what I'm doing too much. I can just kind of paste some stuff in. So that's why I'm going to use overleaf here to finish this assignment. All right, next question. Are you allowed to create the 3 following variables in Java as they are written below? Why or why not? Yeah, you are. Right? That's fine. Like if I actually, I'll find it over here. Int total, total, right? With different capitalizations. If I go to Eclipse, wherever Eclipse is, here it is. Let's erase everything. If I put that in there and I hit run, of course it's fine. It's perfectly fine. Yeah. And the reason for that is that capitalization doesn't matter, right? Or sorry, capitalization does matter. Those are 3 different variable names because the capitalization is different. So to answer this question, right, it says, are you allowed to create them? Why or why not? Well, I can find that question over here in the left-hand panel. It says, are you allowed to create the following 3 variables in Java? Why or why not? Then it has the listing. And then under that, I'll put my answer under that. So I'll just say answer just to make it more obvious. This is the answer. And I say, this is fine because Java is case sensitive. So these are all different variable names because they have different capitalization. So I can just type in my answer, hit recompile, and there's my answer in question 2. Oops. Okay, and then you can move on. What is a byte of data? What is a byte of data? So a byte of data is 8 bits. So I can say answer, a byte is 8 bits. That is 8 zeros or ones. Okay, that's how much data it is. So I typed in my answer, and there it is. Question 3, what is a byte of data? Answer, a byte is 8 bits. That is 8 zeros or ones. Okay, question 4, translate the binary number into decimal format. Well, we haven't talked about that, right? So we're going to have to. So let me go to Notepad here. Let's erase this, and let's talk about this a little bit. So numbers are done in powers of 2. Okay, powers of 2. So if I have a number like this, let's say like, let me just type 1. Okay. So here's a relatively short number. Okay. So the way you interpret this is this. So this first number here, all the way on the right, that's like the ones place. Actually, let me show you. You know what? Sorry. We're going to do this in decimal first, right? If I do this, like if I say 539, right, in decimal, this is a decimal number, right? What that means is this. So this is called, the 9 is called the ones place. So that is like 9 times 1 is what that is. Okay. And then the 3 is in the tens place. So the 3 actually means 3 times 10. So 3 times 10. Right? So 3 times 10 is 30, plus 9 times 1 is 9. So a 9 in the ones place, a 3 in the tens place, and then a 5 in the hundreds place. So 5 times 100, right? That's what 539 means. It means 5 in the hundreds place, 3 in the tens place, 9 in the ones. And then if you went up one more, like if I added like a, I don't know, like a 7 there, that would be the 7 is in the thousands place. So that would be 7 times 1,000, right? And that's just how numbers work, decimal numbers. Now, binary numbers are the same, but binary numbers are the same, except that instead of having, like for decimals, you have a ones place, a tens place, a hundreds place, a thousands place. In binaries, you have a one place, a twos place, a 4, an 8, a 16, a 32, etc. So they're all powers of 2, right? 2, you have 1, which is 2 to the 0, 2, which is 2 to the 1, 2 to the 2, 2 to the 3, which is 8, 2 to the 4, which is 16, 2 to the 5, which is 32, and so on. And so the places are not 1, 10, 100, 1,000. When you have a binary number, like let's say like 1, 0, 1, 1, like that, the places are 1, 2, 4, and 8. Those are the places. Okay, so like this number here, 1011, the way you would interpret this number is the digit furthest to the right is a 1. So that's the ones place. So that's 1 times 1. And then the next one over is in the twos place. So that's also a 1. So that is 2 times 1. And then the 0, it'd be 1 to 2 to 4. So the 0 is in the 4's place. So that would be 0 times 4. And then finally, there is a 1 in the 8's place, right? So this 1's place, 2, 4, 8. So that 1 is in the 8's place. So that's 1 times 8. So then if you add this all up, you would know what number we just wrote down. So 1011 is 8 plus 0, so 8, plus 2, which is 10, plus 1, which will get you to 11. So 1011 is 11. Okay? And that's how you would do this. So for the one that we were given in this problem, which was, I'll find it, scroll down a little bit. Here it is, 10001101. This number, and really that's the same thing as having no space there, 10011101. But they kind of put the space there so like your brain can see that it's 4 and 4. Makes it easier to look at. Okay, and then in terms of what we're going to do, it's exactly the same way. So this is the ones place, 2, 4, 8, 16, 32, 64, 128. So all the way on the left is the 128th place. So then we just added up the way that we did this one up here. And you can start either from the left end, like 1 times 8, or you can start from the other end. So like if I count them up, 1, 2, 4, 8, 16, 32, 64, 128. If I know that this one is a 128, I can go 128 times 1. So I can start on the left end if I know it's at a 128. And then you've got 0 times 64. That would be the next one. So 64 times 0. And then 32. 0 times 32. I guess I was doing... What was it? Oh, I reversed the order that I was doing this. I was putting the binary number first and then the place second. So I'm going to reverse this. 1 times 1, 28. 0 times 64. All right, next one is 0 times 32, 0 times 32, and then 0 times 16. You got word wrap on? Good old notepad. So I'll keep going. So we're on the second group of 4 numbers now, plus, I'm going to make this smaller here. So we have a 1 in the 8th place, so that's 1 times 8. And then another 1, that would be the 4's place, 1 times 4. A 0 in the 2's place, so that's 0 times 2. And then a 1 in the 1's place, so plus 1 times 1. So you add these all up, and that's your number. So, you'd grab a calculator or something, but just kind of, we have 128 from here, and then 0, 0, 0, 8. So 128 plus 8 plus 4 plus 4. I guess I don't need these spaces. And then no 2, and then a 1. So plus 1. So it's 128 plus 8 plus 4 plus 1. So 128 plus 8 is 136, plus 4 is 140, plus 1 is 141. So this is 141. Okay? So that's the answer. It's 141. Now, if you need a calculator, there are lots of calculators out there. So if you just Googled binary conversion, something like that, there'll be a bunch of them. I'll just take this first one, binary converter, rapid tables, and they have the number, and we'll just type it in. So it was, what was it? 1000, 1000, 1101, 1101, hit convert. Decimal, it is 141, right? So that's what we just did. We just added that up by hand. So it's 141, and it says translate the number into decimal format. Answer 141. Hit recompile. If you are using Overleaf, every time you make a change, hit recompile, because if you don't do that, you're going to find out sooner or later that you accidentally erased one of these things that you need, and it doesn't compile anymore, right? So pretend you're writing programming code where every time you make one change, hit recompile. And then that way, if you break something, you'll know immediately instead of, 20 minutes from now. Okay, so we did that. Translate that. Let's check time, and then we'll do a little bit more. 58. We'll go a little bit further. So the next problem says, give the declaration for 3 variables called height, width, and length. All the variables are of the type double and should be initialized to 0. I mean, that's going to be really easy. So I can just show you in Eclipse, right? We have Eclipse. Well, what do they say? They're called height, length, width. I think I did that in the wrong order, but it doesn't matter. They should be type double. Okay. And they should be initialized to 0. So that means just equals 0, equals 0, equals 0. Now, if I run this, I should not get an error, which I do not, and everything's fine. So that's one way to do it if you want to do it all on one line. If you want different lines, you can. I'll do it 3 different lines. But you have to make sure to put semicolons on the end of each line. And on each line, you have to say double variable name equals and then 0.0. And you do want it, it doesn't matter for 0, but you could, you don't want to put in 0 with no period, because when you do that, the compiler thinks you're typing an integer. And you're not typing an integer, you're trying to type in a decimal number. And so to be on the safe side, even though 0 is 0, type it in as a decimal if you want it to be treated like a decimal. Better safe than sorry. It doesn't matter here, but it matters sometimes. Okay, like for example, here, let me do this. Let me show you. System.out. Let's just do print line. Let's do this. So let's say height is plus, and I'm going to say height. Okay. Put a semicolon at the end. Let's run this. Height is 0.0. Now, if I put in like 5.2, you can guess what's going to happen. 5.2. If I put in 2.0 over 3.0, what are we going to get? 2 over 3 is 2/3, right? 0.666667, right? Okay, there it is. And if I do this, 2 over 3, I get 0. Remember from last time? If you write them as integers, the compiler does the operation 2 divided by 3 as integers, which means any decimal gets thrown away. So 2 over 3 is 0. 0. Bunch of sixes. And then if you throw away the decimal part, you just have 0 left, right? You're just throwing away what's left. Everything after the decimal point, which is 0. So that's why that happens. And so to avoid issues like that, sometimes you'll see somebody just do that. That's fine, but this is better. So that's how you avoid this kind of issue, is by typing in decimals as decimals. All right, so this is one way to do it. So I'll copy that, and I need to paste it in my PDF here. So this is problem 5. Go down, give the declaration. I see where it is. And so here's how I'll do this. So I want the code right here, right? In between these two lines. Before the next problem, give the declaration for 3 variables. So I'll put it there, but it's not going to format it correctly, right? I'm going to hit recompile to show you. Right? It did not print that very well. I mean, technically that's okay. But if I wanted to format it like I did up here for these things, then remember what I said, it has to be between these listing things. So you would just, where are we here? Right above that, I'll do, it's actually a backslash, and begin, curly braces, LST listing. And then when the code is done, end LST listing, like that. And if I do that and hit recompile, now I've got it, formatted the way that I've been formatting stuff. Okay. And then I think we'll do one more and then we'll stop for today, I think. So then problem 6, which is now kind of awkwardly placed here. You can, by the way, if you need it to go, if you look at this, actually do look at this. And so you see how it says 6, convert each of the following mathematical formulas to Java, and then the rest of the problem is on the next page. Wouldn't it be better, like, I should just move 6 down to the next page, right? So the way you would have to do that is where you want that to happen, which is right before convert the following mathematical formulas to a Java expression. If you want it to go to a new page, right before that, you just do backslash new page. Hit recompile, and now it's on the next page. Okay. Now it says convert each of the following to Java expressions. That's easy. You just have to, that's what we did right before we started this assignment as we looked at this. So let's just move this over here. Can we see it? I don't know if let's do this. Barely looking at the screen here. So here it is. Convert each of the following. So if you want to do 5x, how do you say 5x? You say 5x as 5 times x. That's how you do it. this is not going to run, right? But that's how you do it. You say 5 times x. When you want to say 7x plus z, you have to say 7 times x plus z. Usually you like to leave spaces if you can. If you want a fraction, x minus y over 7, you remember you have to put the entire numerator in parentheses. So if you need x minus y in the numerator, you open parentheses, x minus y, close parentheses. Then you can do your division. So you slash for the division, 7. And then finally, 7x plus 9 on top, x times y on the bottom. That would be open parentheses, 7 times x plus 9, close parentheses, there's your numerator, slash, denominator, open parentheses again, x times y, right? So keep the entire numerator and the entire denominator in parentheses if you want to avoid, errors. Okay. Now, those are not full statements that compile in Java, but this is the correct syntax for how to write these expressions. So I'll hit Control C, go back over to my web browser, which is gone now, and convert each of the following. And so below that, I'm going to put code again. So I'm going to say begin LST listing, close curly braces. It added the end for me this time by itself, and I'll just Control paste. Control V, just paste. All right, there they are. And I didn't match them up with, where they are, but, I did them in order. It's understandable. What are 7 mathematical operators used in Java? I don't know, but let's copy one of these listings, put it there, and then what are they? Mathematical operations. How about there's a minus? What would you use a minus for, right? Negating a variable. All right. How about a plus? That's another one. Adding two things. Add, subtract, multiply. / divide. Okay, that's 4. We need 3 more. What else can we do? Right? Got to figure it out. 7 mathematical operators. What are they used for? So we start to run out. Another one you might think of is exponents. How would you do that? We haven't really seen that, but exponents in Java. So, blah, 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 blah. This is probably not what we want here. And let me go back. Let's actually just do it in Eclipse and we'll figure it out ourselves. Okay. So let's go here. All right, height, fine. No A. Let's delete that. Integer A equals, let's say 2. Right? If I run this, of course, it's going to say A is 2. A is 2. And if I do A times, let's say, 5, A is 10. If I do A equals 2 asterisk 5, run. Oh, okay, that's not. It doesn't work. So what do we have? So I guess if we have to use a pow if we want a power. So we just want to list. Oh, we didn't do remainder. We should have done that one already, right? We know about remainder, which is the modulo or mod command, right? This one, when we go like Remember, like 15, 2, right? But no, let's do like 6. Like 15% 6, it would do 15 divided by 6 is 2, but there's 3 left over, right? So that's going to be 3. A is 3. So that's the modulo command or remainder operation, modulo or remainder. So that's this one. Remainder. What else we got? Oh, we got plus pluses and minuses, right? How many do we have? 1, 2, 3, 4, 5. So we can go about plus plus, add 1, minus minus, subtracts 1. And also, here's a new one that we haven't talked about, so I'm just going to tell you so we have one. So let's do this. Let me say A is 5, okay? So first start out, A is 5. Now, if I do this, A times equals, asterisk equals, and I do, I don't know, let's say 8. Run. What do we get? We get 40. So what happened here? So A times equals 8 is shorthand for this. It's shorthand for A equals A times 8. That's what that's shorthand for. So we can, that's an operator, times equals. So we can use that. So, you know, we can write the whole thing if we think people won't understand what we're doing. Like we can do like A, B. That's A equals A times B. That's what that one does. How many are we up to? We did 1, 2, 3, 4, 5, 6, 7, 8. Okay, we did it. Right? Just look them up, find some. Okay, 2 ways you can make a new blank line in your output in Java. A new blank line, I think they mean go to the next line. So one way to do it, actually, let me do a few of these here. So let's use print. A is. Now let's do kind of maybe first. Second. Third. Run. And it goes first, second, third, all one word, right? So one way to get a new line is when you're done doing your text, so like first, and I want to go to a new line, I can add a \n. \n means new line. So that's called the new line character. Okay? Run. So you see now it does that. That's one way to do it. Another way to do it is to use the println, which we know after it finishes that line, it's going to go to the next line. And so those are 2 easy ways to do it. There are probably going to be others. Okay, so how would I say this? I mean, I could use an example. So I could say our answer, actually I'll put my answer in a begin, LSTLISTING, and I'll put those lines in there, and you can say what they do. I'll say it with a comment. I'll go right above it, and I'll go \\. No, the // for a comment, and I'll say use the \n in a system.out.print. That's one way to get a new line, and the other would be to use system.out.println, which always ends in a new line, not new line, a new line. So I just say what I'm doing there, hit recompile, and there you go. That's not that readable. What happened? Just lining everything up here. So hopefully it looks a little nicer. Maybe I'll put a blank line between those. Okay, that's a slightly nicer looking. There are two ways to make a new blank line. It doesn't really make a blank line, it goes to the next line, and the next line is blank already. Okay, and then the last two problems involve, well, we could technically do the last one now, but we'll do them both next time because problem 9 involves a if statement, which is flow control, which is branching, which we will do next time. Okay, so I think that's going to be it for now. Consider using this website to do your work the way I'm doing it here, but you don't have to. But I'll tell you the advantages. The advantages are when you're done, you just can hit the download PDF button and get your PDF. And if you leave this site, so I just hit close, I'm not saving anything, I just hit close, and I go back to Overleaf, my lab is right there where I left it, exactly how I left it. Okay, so I like having stuff in Overleaf, and if I go home here, you'll see that I use it a lot, right? See, you can scroll through. I have lots of documents here, and I think it's really useful to have, right? I have my notes for here's notes for Calculus 2 class that I teach. And see how nice these look? Look at that. Professional. Amazing, right? It's good software to learn how to use. And so, may as well start learning it now. It'll help you in the future. If you don't like it, use Microsoft Word and ignore anything I say about Overleaf. Okay, so that's going to be it for now. See you guys on Wednesday.